There are many types of nanoparticles used in biomedical imaging. Certainly the most popular are quantum dots, which are semiconducting nanoparticles, or gold nanoparticles. But you also see iron oxide, which are known as ferrofluids, so-called core shell nanoparticles, iron cobalt, liposomes for drug delivery systems, perfluorocarbons, carbon nanotubes, and one of my favorites are dendrimers. In the freshman course, we have students make what are called ferrofluids. These are Fe3O4 nanoparticle suspensions. Basically, you mix iron 2 and iron 3 chloride salts and then add ammonium hydroxide to that, and that basically titrates the acid that the chlorides are dissolved in. You wind up then capping the nanoparticles with a surfactant, and then students have fun watching the nanoparticle suspension spike up. Applications for this include advanced braking systems for vehicles, as well as opening doors on the International Space Station. This ferrofluid synthesis is easy enough that we use it for our outreach program sometimes to the Space Coast Society of Women Engineers. They have a program called Wow, That's Engineering, geared toward 7th to 10th grade girls. They also have an introducing girls to engineering to 3rd to 6th grade girls that we sometimes use a different program as part of our outreach. A synthesis that's easy enough to do as part of our first course in nanotechnology, but we usually do it in our second course as the first experiment, involves Cad sulfide nanoparticles. This experiment was developed by Professor Kurt Winkleman of our chemistry department, and you can see the color differences between bulk Cad sulfide, which is an orange, a burnt orange, and the nano is in the yellow range. In our nanotech minor, students get exposed to a wide variety of analytical methods, scanning electron and transmission electron microscopy, scanning tunneling and atomic force microscopy, confocal laser scanning microscopy for biological samples, UV-Vis and Raman spectroscopies, fluorescence-based spectroscopies, particle size analysis, zeta potential analysis to measure surface charge on the nanoparticles. We then have different molecules to stick, that's called chemisorption, as well as liquid nitrogen porosimetry to measure the surface area, pore volume, and pore size distribution. Now, earlier I said that leadership means never resting on your laurels. For me, that means that I'm constantly buying and refurbishing old equipment to add to our capabilities. I'd like to raise money to hire a friend of mine named Neil Wright to mentor students in our biology, chemistry, chemical engineering, and biomedical engineering departments, as well as refurbish a lot of old equipment that I have awaiting entrepreneurially minded students to repair. Students enjoy using our transmission electron microscope despite the fact that it's a somewhat old instrument, and it would be much better if we had a higher voltage one for research purposes. RTEM is an excellent one for training students, but it's old enough now. If you look at the bottom of the screen underneath the Zeiss, it says West Germany, so yes, it was built in the 1980s. It's great for training students, but Zeiss won't support it anymore. A short-term watt for our nanotech minor program is $10,000 for a repair budget for our transmission and our scanning electron microscopes, and $200,000 for a DeLong America benchtop combination scanning and transmission electron microscope. If we only had $60,000 donated by somebody, we'd get a Phenom desktop SEM from Nanoscience Instruments. Earlier I talked about Cad sulfide nanoparticles. This is the first in a series of TEM images where you're going to see what I call a pea pod containing cad sulfide nanoparticles, and we're literally going to burn holes in the pea pod and then see the cad sulfide nanoparticles act. Now that we're starting to burn holes in the pea pod, you can see little round empty shapes. These are called micelles. They're roughly 5 nanometers in diameter, and they contain the cad sulfide nanoparticles. The white arrow near the upper right shows the initial rupture of the outer hull of the pea pod structure that surrounds the nanoparticles. Now not only is there damage to the outer hull, but one can see fibrous structures that the cad sulfide nanoparticles are spherical ends on those fibrous structures, and you can see those from the white arrows.